Welcome everybody. My name is Arash Yazdani, and I'm the Director of Engineering with PRI Engineering. And I just wanted to welcome everybody and thank you for joining us for our webinar on geotechnical engineering for solar foundation design. So just quickly wanted to talk about today's agenda, and we're going to start with an introduction to PRI Engineering. Then we're going to talk about the basics of solar racking foundation design and the inputs. We're going to talk about the geotechnical investigation process for solar racking design, which includes subsurface investigation and a pre-production testing program. Then we're going to talk a little bit about construction QA, QC, production testing, and we're going to finish off with questions. So to start us off, I wanted to tell everybody a little bit about PRI Engineering. My name is Arash Yazdani. I'm a licensed engineer, and I lead and oversee the operations at PRI Engineering. I've invited a close colleague of mine, Vishal Lala, the managing director of Polar Racking, to join us. He's going to talk a little bit about the aspects of solar racking foundation design from a racking manufacturer's standpoint. To provide a little bit of history of PRI Engineering, PRI Engineering did start as the engineering division of Polar Racking. That started when I joined the team 3 years ago. I am a geotechnical engineer, and I helped Polar Racking build their ground mount division. From there, we had quite a few customers that wanted us to look at designing foundations for other racking systems, particularly in the single axis tracker space, which specifically in the single axis tracker space. And so from there, we did a couple projects, and we definitely recognized that there was a huge need for this type of service in Canada and in parts of the United States. So that's where we officially started PRI Engineering. So PRI Engineering today is its own separate entity, and has a full management team that's separate from Polar Racking. But nonetheless, we do work very closely with Polar. PRI Engineering is a team of 9 engineers and technologists. We service the Canada, the United States, particularly some cold climate regions, let's say, of the United States, but we have done lots of work in the southern parts as well as the Caribbean. We've got 4 licensed engineers on staff, including 3 geotechnical engineers and 1 structural engineer. And PRI Engineering has a combined 1.5 gigawatts of total design and construction oversight experience with respect to solar racking foundation design. And over that 1.5 gigawatts, we've acted as the engineer of record, we've acted as the owner's engineer, we've done quality control, we've done just testing. We've more or less worn every hat that you could in the whole foundation design and erection process. On top of that, I did mention our relationship with Polar Racking, but we've got very, very good relationships with a variety of other racking manufacturers. Myself and my team have worked very closely with systems such as Solar Flex Rack, GP Joule, Axis, Next Tracker, PV Harper, just to name a few. Having worked with that many racking manufacturers, if a new one comes to us, we know the questions to ask, we know the information we need from the racking manufacturer, which really allows us to kind of fast track the process compared to a more traditional engineering firm that does not focus on solar. While we do have a focus on solar, our team of engineers and technologists have a very diverse background in a multitude of other disciplines and other types of projects. Specifically the ones that come to mind is municipal infrastructure projects, roads, bridges, sewers, water mains. And because essentially a large solar project is a large infrastructure project. So, the purpose of this webinar today is to focus on the racking foundation, but our team has a lot of other experiences that can assist in the development and engineering works and design for other portions of a solar farm. And finally, it's worth mentioning that currently PRI Engineering is in the process of developing its own in-house concrete and soils lab, and we are going to be focusing on some more specific, let's call it solar-specific soils analysis programs that's going to help provide our customers with better service. Okay, so the solar racking foundation design process. These are a list of things that need to be considered in advance of doing your geotechnical field investigation. So those design considerations include racking induced loads. So that would all come from the racking manufacturer. And, like I mentioned, we've got a lot of experience working with a lot of different racking manufacturers. But so we know the questions to ask, we know the information that we're looking for. So that usually streamlines that process. The information we get from them usually comes in the form of reaction loads, and they will combine and factor the racking dead load, the wind load, the snow load, and the seismic loads for that project. And then the geotechnical considerations is the frost design depth and the add freeze pressure. And we will start with some preliminary assumptions on what those will be, but those are specific details that are confirmed during the geotechnical investigation. So to start off with the racking induced loads, just to briefly go over what those represent. The first one is the wind loads. So the picture on the right is the photo of a racking model in a wind tunnel. So the wind loads are based on racking specific wind tunnel study typically. Some manufacturers only have like a desktop study, and others have a specific model that was completed for their specific rack. This is a picture of a specific rack in a wind tunnel for specific testing. In the absence of that information, there is the opportunity to kind of look at the local building authority recommendations in the building code. But typically that's going to result in a over-engineered design or a super conservative design. So this is why most racking suppliers at least opt to do a desktop wind tunnel study or a racking specific wind tunnel study. Then we need to consider the snow loads. Snow loads come from local building authorities. You could do local accumulation studies for the area, but that is kind of uncommon. Being in the northern regions of the United States and in Canada, obviously snow loading is a big issue, not only for racking structures, for all types of buildings. So there's a lot of historical data that we can leverage on that front to make sure that we're determining the appropriate snow loads. Finally, seismic loads, not something that's typically a worry in the Northeast United States, but obviously as you make your way to the Ring of Fire on the West Coast in Canada and the United States, seismic loading is a big consideration. Typically, seismic loading is based on statistical data, which is published by the local authorities, and it's also some considerations need to consider the actual subsurface conditions, specifically your water conditions and the type of soils that you've encountered in the subsurface. One of the largest risks in solar foundation design in northern climates is frost. So the frost design depth is an extremely important parameter to be determined. It can be determined based on local climatic data and recommendations from the local building authorities. At PRI, we actually do a specific calculation based on available data from local climatic stations to determine the frost depth return for a certain design period. Alternatively, you could just look at the local building authority recommendations, but that would typically be conservative. Add freeze pressure. So add freeze pressure is essentially the expansion of water in the pores of soils, which is the force that is then acting on the pile. We're actually very, very happy to announce that we're in the process of finalizing a research initiative with an academic institution where we're looking at providing some more guidelines for the add freeze pressures. So stay tuned, keep your eyes tuned to our LinkedIn or other social media pages. We'll be making announcements shortly about that endeavor with the academic institution. And the goals would be to build on the recommendations which are in the Canadian Foundation Engineering Manual. Now, one thing about add freeze pressure recommendations, whether we're working in the United States or Canada, we're referencing the Canadian Foundation Engineering Manual because actually, believe it or not, internationally, this is one of the best guidelines out there in terms of determining add freeze pressures. And there isn't much literature, particularly in the ASCE structural guidelines on this topic, and hence why we've recognized that this is a major contributor to the design and total length and final orientation of the foundation of a racking system, and that's why we've decided to take on that academic initiative. So once you've got all that information determined, you would be ready to do your subsurface investigation. So on the subsurface investigation, we always recommend to our customers to start with a preliminary site visit. So what the preliminary site visit looks like is, typically the developer or the constructor, depending on how the project is being rolled out, will have a proposed array location. During the preliminary site visit, what we recommend is we always like to have the owner on site with us. We do a walk through the site and we take a look at the array area and we try to identify anything at surface that may create some problematic conditions in the underground. Some examples of that might be, you've got a 10-acre site and in the southwest corner, maybe you've got a low spot that's collecting water. That might be an area where you have some additional issues, some additional constraints, some additional design challenges that you need to work through. And so, right off the hop, we would kind of look at seeing if we could work with the owner, work with the developer to potentially repurpose that portion of the property to another part of the land to really, reduce the risk of the construction of foundation erection and ultimately resulting in a cheaper and easier to install foundation. PRI, we really try to push our customers to do test pits over boreholes. And the reason for this is one of the largest, let's say, enemies of solar racking foundations is obstructions. Some of the more common types of foundations are driven piles or screw piles, both of which don't do very well against large boulders and cobbles. So for those of you that aren't familiar with a borehole, a borehole is essentially a 6 to 8 inch boring where you're pushing a tube into the ground to take samples. So that tube is 2 inches in diameter. So if you've got a 6 or an 8 or a 12-inch diameter boulder, it's going to be kind of hard to tell from a 6-inch hole what you're coming against. If you're getting down to 10 feet and you're continuously hitting something that you can't get past, it's really hard and difficult to quantify what that is with a borehole. But with a test pit, you're looking, you'd excavate a test pit, you're looking down into the hole, and you can see the obstructions right in front of you. So it's much easier to quantify what the constructability of your foundation will be from a test pit. So that's why we really push and propose to do test pits. The other reason for that is, the typical length of a solar foundation is kind of in the 3 to 4.5 meter range. We can investigate with a test bit very easily to 3.5 meters. Now I know, I just finished saying that, your foundation could be up to 4.5 meters. That leaves a meter of unexplored depth. However, that's why we really like to push doing a pre-production program coupled with the test bit program, which I'll get into a little bit later. So the other part of that is a lot of these piles are loaded in an uplift. They're loaded with uplift, so that's an upwards force. And because of that, a lot of your stress isn't being transferred below. A lot of it is dependent on what is happening in that upper 3 to 4 meters. So that's where, the test bits really allows us to assess what's going on in that upper zone. With the test bits, we are doing in situ testing, which provides us some very similar parameters as standard penetration tests, SPTs, which you would get from a borehole, which allows us to estimate the shear strength of the soil very similarly to a borehole. So we are able to infer a lot of the engineering classification and properties from a test bit by doing a lot of these in situ tests. So from that subsurface investigation, we're able to develop a subsurface profile for preliminary pile design. So from that, we would have a pretty good idea of what your best option for a foundation is. Prior to coming to site, we would have done a background review of published information to try and at least get an idea of what is in the subsurface. And then so in a lot of cases, the test bits is hopefully just confirming what the background review we've done is saying. And in light of that, we've got a couple candidates for potential pile designs ahead of time, and we're just confirming that these designs make sense, and maybe we're taking a list of 3 and narrowing it down to 2 or maybe even 1. So at that stage, we would then move into pre-production testing. So this is really where PRI Engineering is going to differ from your more traditional engineering firms that won't be focusing on solar. We really encourage our customers to look at the geotechnical investigation, doing the test bits, doing the test bits at the same time as or coupled together with the pre-production testing. Those of you that have received or had anybody do a geotechnical investigation report for you in the past, I can pretty much guarantee you I know what the final conclusion is, and 9.5 times out of 10, that report is going to tell you, we encountered these types of materials, we encountered those types of materials, and you should consider this as your potential design, but ultimately you should ground truth it all with a pile testing program. So when we know that 95% of the time you're going to end up doing a pre-production testing program anyways, why are we not doing that up front? If we do that up front, when we do the test bits, we save you a mobilization. We save you time with your schedule. So instead of 2 construction crews going out to do 2 separate operations over the span of 10 weeks or 12 weeks, we can do 1 mobilization with 1 crew over a 6 to 8 week period. So that allows you to kind of make sure that you're doing the right investigation. Make sure you got all that information from the racking company determined ahead of time. It buys you a little bit of time, and it's going to ultimately save you costs. That you're going to be doing this regardless, so it makes sense. And we've had a lot of customers that have done both, and like I said, 9.5 times out of 10, they would agree that we did the right thing by doing it all in one shot. So pre-production testing is essentially verifying your design assumptions. So as I mentioned, during the actual geotechnical investigation, we'll be developing geotechnical design parameters that would be then fed into the pile design. We would be then verifying those pile design assumptions during this pre-production testing program. The other major thing that we are trying to get out of this is we're assessing constructability. I'm sure the contractors in attendance today will get a breath of fresh air when I say, there's unfortunately way too many designs out there that just haven't been thought about from a constructability standpoint. So during the pre-production testing program, we're not only verifying our design assumptions, we're also seeing if it's going to be possible to replicate this design 7,000 times, 100,000 times, 200,000 times, across an area of 10 acres, 50 acres, 700 acres, whatever have you, because every time that your constructor has to stop and think, that's money out of your pocket. That you're probably being charged a standby rate. So you need to have an appreciation and understanding and really a comfort level that not only is this design look good, it's going to be sturdy, but it's also going to be easy to install, so that when you get a quote from a contractor that says it's going to cost you $100,000, you're not hit with an extra $50,000 of extras on change orders because the engineer that designed the pile didn't really think about constructability. So when we're talking about constructability, one of the big things we're looking into is subsurface consistency. The picture behind you is a helical pile installation. So in a lot of cases, like I said earlier, a helical pile is its biggest the biggest risk to a helical pile is a large boulder or cobble. You could imagine if a boulder or cobble, maybe the size of my head, was to get in the path of that helical blade that you see beside that Cat 420, that it wouldn't allow it to be advanced to the target embedment depth. If we've got a good idea of how many of these piles are not going to meet their target embedment depth, we've got the ability to develop remediation designs ahead of time. So what I mean by that is, if we know that maybe on this site in particular, one of the corners has a really dense cobble and boulder layer at 6 feet, and our target embedment's 7, we know we need to come up with a design that allows us to terminate that pile at 6 feet, so that when that condition arises, the contractor is just going back, he's just flipping the page in his design document and just going to drawing number 2, which is the remediation option for when you haven't met the embedment depth required in the status quo design number 1. So as I mentioned before, this significantly reduces your risk during construction. And the other thing, it optimizes your design and your cost. Furthermore, like if you're able to get ahead of what you're going to need for remediation, you could build in 10% remediation right into your tender documents, right into your bid documents, so that the contractor is giving you a competitive unit rate to do remediation on the 10% of that project. The other thing is by doing testing, we're verifying those design assumptions. A lot of those design assumptions come from empirical methods, the traditional pen and paper and calculator crunching numbers from the in situ data that we collected from the geotechnical investigation. Ultimately, you're drawing information, we're drawing generalizations for a very heterogeneous material. Soil is not consistent like steel is. So we've got to verify those design assumptions, and by verifying those design assumptions, we're able to further optimize our design. If you've got 100,000 piles and we're able to chop 1 foot off your pile, that's a lot of money. So that's what I mean by optimization of designs and costs. Production testing. So production testing is essentially the verification of the design during the construction phase. We're also looking at testing of non-conforming piles. We do a lot of homework ahead of time to try to identify what could go wrong. Sometimes we've done an adequate amount of homework and we know exactly what we're up against. In other situations, conditions may have arose, or we may have not done adequate homework and issues arise and we need to assess those during the production phase. So we are doing production testing throughout the process of construction to really mitigate the risk for the owners and general contractors in real time. So what I mean by that is the way a foundation contractor should be approaching a solar farm is like a manufacturing process. You need your contractor to go through these sites like an assembly line. So what I mean by that is, if you've got 1,000 points that you've got to install piles, if you're going along that line and you get to pile number 4 and then all of a sudden you have to skip it over, and then you get to pile number 5 and you got to skip over, and then you're good at 6, you're good at 7, you're good at 8, but then you got to skip over 9, 10, 11. If you don't have if you don't have somebody monitoring this in real time, and all of a sudden, next thing you know, the contractor's in the complete opposite corner of the site, and you've got your racking crew coming in behind them, and they get to table 1 and they're like, well, we can't rack. We're missing pile 3. And then you get it to rack number 2, and they say, well, we can't rack because we're in pile number 2. And you keep going and going and going, and next thing you know, the pile installer, like I said, he's on the complete opposite side of the site, and your racking installer has gone through the field and he's identified basically that he can't install anywhere. By providing you real-time monitoring of what's happening in the construction phase, we're able to help you provide solutions right away, so that hopefully if we get the information well enough in advance, or while it's being collected, we can propose recommendations for designs before that contractor ends up in the complete opposite corner. Because what might happen if he ends up in that opposite corner is it may take him 2 hours out of his day to mobilize from that corner to your spot, set up for one pile, and then go back to where he was working. You will pay a premium for that as the general or the owner, depending on how you got your contract set up. So that's what we want to really help you avoid. By monitoring the installation in real time, you're going to get solutions in real time. We're going to talk a little bit more about construction inspection services at PRI Engineering on October 8th in a webinar to follow. We're going to talk a little bit about different types of foundations. We have talked a little bit about foundations, but we're going to talk about different foundations, what type of ground conditions are most suitable for the different types of foundations out there, remediation options for different foundations, and we're also going to look at a couple case studies. At this point, I'm going to turn it over to my colleague and friend, Vishal Lala, who's the Managing Director of Polar Racking, and he's going to tell you a little bit about the benefits of working with a engineering firm that understands the dynamics of solar racking foundation design from a racking standpoint. And as mentioned, we've got a variety of experiences and we've got very good relationships with a lot of racking providers. So don't think that if you're not using Polar that you can't use PRI. You definitely can. However, in a lot of circumstances, you'll definitely see the benefit of the synergies by utilizing both companies. Go ahead.
Thanks a lot, Arash. I really appreciate that handoff, and lots of good information. I can tell you from being in the solar industry for the last 11 years, there's lots of people that have come and gone and lots that we've learned. And now moving into new markets, we're seeing people make the same mistakes that were made here in Ontario in 2009, 10, and 11, happening out east and happening in some of the northern provinces and even in the Midwest, U.S. projects. So some of the benefits that I want to highlight real quick is, again, being on the racking side and working with different developers and contractors. Oftentimes, we are handing off our design loads to outside engineering firms, and they're taking them, they're designing foundations. And, usually one of two things come back. It's a very, shallow, driven foundation in a place that we know has lots of deep frost, or it's a huge, gigantic, oversized pile design. And, in which case we know that, the owner, in both cases, actually, in one side, the owner is taking too much risk, and the other side, the owner's paying too much money, and not having risk. And in both cases, it's as a result of working with engineering companies that just don't understand the application. So, traditional geotechnical firms are always, or not always, but, in general, working on, larger infrastructure projects or even residential applications where a site will have, 5, 10, 50 piles, let's say. Solar is very unique, and therefore working with an expert that understands the application, that's seen the good, the bad, the ugly, and can come up with a solution is definitely, a big advantage to, the developers out there and the contractors out there that are going to do the work. And at least you have confidence to know you're working with someone that specializes in the application, and understands, what you're getting yourself into, and what typically the capabilities are of the contractors on site to be able to deal with issues. There's no point in suggesting a solution that's unfeasible for what the application is and that's being done. These are shallow foundations for the most part, and there's lots of them. So it is a very specialized expertise, and PRI does, a great job working not only with us, with us it's very seamless in the background, but I've seen it, with others as well, to come up with solutions and to come up with designs that are very installable in the field. I'll just take a couple of seconds and then we'll just open it up to questions. On the geotech side, just wanted to let you know that, Polar and PRI is obviously, we let the ground tell us what the right foundation is to put in. So, 100% foundation agnostic, if you want to call it that way. And we're able, once you do have a foundation design, we're able to help, whether if it's our racking or not, supply ground screws, helical piles, different types of driven foundations, whether it be W sections or round posts. So there's lots of benefits there. So once you get your foundation design, please definitely consider us for the supply side as well. Can we go to the next slide? Rash, I believe you're controlling the slide, so if you could just move it to the next slide, that would be great. Yeah, so just this two seconds about Polar, founded in 2009, like I said, worked all over North America and the Caribbean, and here's some of our contact information in case you are looking for supply of any of the different types of foundation that we've talked about today. Just a quick summary that, we, at Polar here, we do supply rooftop racking solutions. And again, PRI has structural engineer to evaluate your roof and to provide you with ballast plans for flat roof and connections for flush mount roofing applications. We have ground mount products for your small and your large scale fixed ground mount solutions. And we have carports, again, something that we work closely with PRI on in terms of designing foundations for carports all over Canada and the US as well. So I'll pass it back to Arash right now and open it up for questions about any of the topics that we presented here today.
Okay, thank you very much, Vishal, for that. Yeah, so overall, just wanted to thank everybody. We do have time for some questions. There is, I believe, some questions already in the chat, but by all means, if you've got more, just bear with me as I figure out how to get that. Okay, so I think the first question is, just bear with me.
Here, I'll jump on the first question. It was from Peter saying, will there be a copy of the webinar available? And yes, definitely after this is done, we're making a recording right now, and we'll be sending out a thank you to all of you for attending, as well as a link for you to review the webinar at your leisure, and you know, share it with colleagues as you suggested that we're not able to make it today.
Okay, very good. Okay, so I've got questions in front of me. So the first question is from Whale Musa. Sorry if I've pronounced your name incorrectly, but the question is, how many test pits or borehole recommended per area, or a pile or foundations? So that's a very good question. What we typically recommend is we would have a standard number of test pits for a certain size of site. For example, you know, let's say you got like a 25, 30 acre site, you know, that's going to be kind of in the community solar size of project. We'd recommend about 20 to 25 test pits. You could maybe get that down to 15 test pits. One thing I really want to stress here, though, is back to Vishal's comment, we really got to let the ground do the talking for us. So we might start with 15 test pits, and if we're finding extremely consistent conditions across the site, we're probably good with 15 test pits. But if we find that there's some very, very, very drastic changes spatially across the site, and you've got different soil types and different ground conditions and different groundwater conditions, and you know, you've got, you know, different depths to bedrock, you know, a lot of these factors have a major contribution to the final design. So in those cases, we may recommend to you, hey, you know, it might make sense to do another 10 test pits in this area over here because, you know, we found a very variable depth to bedrock. Or, hey, it might make sense to do a couple more test pits in here because we found an extremely soft clay layer, which is definitely needs to be analyzed a little bit closer and needs to be looked at a little bit closer from a foundation resilience standpoint. So, you know, so hopefully to answer your question, like I said, you know, something in the 25 acre range, we'd probably recommend something in the 15 to 20 test pits. However, I always like to look at projects on a case-by-case basis. And, you know, if you have a project specifically you want us to take a look at, you know, feel free to send over the details to the email on the screen right now. And either myself or somebody on my team would be happy to take a look and, you know, provide you a preliminary proposal on what could be completed. So the next question is, what solutions do you recommend for rocky soil types? And that's from Barrett. So I would say two things. Number one, a good soil type, or sorry, a good foundation type for, let's say, rocky soils is ground screws. So if you remember back to the foundation slide that Vishal presented, it showed like what looked like a big wood screw. So that's a good pile for a rocky condition. The other thing that we actually had a really interesting site in Alberta where they were having zero success with helicals. They really wanted to do helicals, but the helicals kept getting premature refusal at about 4 or 5 feet. In that case, what we did is we actually used a driven round post, and the benefits to that is you can use the energy that is being used to install the pump to the ground is being used to displace the obstruction. So once again, if we're talking about rocky ground, boulders and cobbles, driven piles, ground screws would be probably where I would start. Of course, back to, our process, I'd be doing the test bits ahead of time. I'd have it in the back of my head that, hey, we want to probably look at driven piles and ground screws. However, we want to kind of assess that with test bits to determine the feasibility and then actually do a construction feasibility part. Can everybody hear me okay?
Yeah, it's cutting a little bit.
Overall, it's good.
Okay. Okay, so I hope that answered the question about foundation types for rocky soils. Okay, so the next question comes from Michael K. Do you have any experience working in Florida, high wind coastal solutions, including carports, pavilions, others? So that's a very good question. I mean, obviously, when you think about somebody from Canada that specializes in design for northern climates, you probably don't think of a project in Florida as something that would kind of suit our expertise. But one of the interesting things is wind generates uplift. Back to one of my first slides during the presentation, frost is ultimately a very, very large uplift load. So from that standpoint, we do have a very good understanding of uplift. And actually, I can say that right now we're working on a project south of Florida, where the reason we were selected as the designers for that project was because of our understanding of uplift design. So, from a mechanism standpoint, wind is an uplift load like frost. There is a bit of a difference between wind in the sense that it's a transient load. So what that means is that it's not a long-term sustained load like a frost load is. A frost load is going to act on the pile and it's going to act over a long period of time. A wind load, in whether you're in Canada or the U.S., it's well recognized that it's what we call a gust load. So you have your uplift occur, but then when the wind softens, that loading stops. But when you have frost and the ground freezes, it's sustained over a long period. Fact of the matter is, though, you still need to obviously have, whether you're holding something for 10, 15 seconds or hours and days, the philosophy of the design is the same. So to answer your question, yes, we can definitely help with high wind areas such as coastal zones of the southern United States. Okay, so next question from JP, and he asks, how do you recommend handling very small sites where the cost of geotech investigation can't be justified? It's a very good question, and I'll be honest, this is one that I've kind of wrestled with on a multitude of projects, and if actually it's the JP I think it is one of the projects you and I were working on together comes to mind. The only thing I can really recommend there is you either need to do one of two things. We either need to have some background information that we can obviously reduce our design assumption risks, or you need to have an installer that has a little bit of flexibility. And what I mean by that is, two of the kind of more common foundations are, or I'd say maybe let's say three of the more common foundations are helical piles, ground screws, and driven piles. So if you've got a smaller system and you know that you are going to be using one of those three systems, it's very beneficial if you can select a pile contractor that has the ability to maybe install a multitude of foundations with the same piece of equipment. The equipment required to install a ground screw and a helical is more or less identical. You need a drive head, which can be connected to an excavator or a bobcat, which would then get connected to the hydraulic lines of the drive head, and that would screw that foundation into the ground. There is also a hydraulic connection piece for a pile driver. And we're actually currently working with a couple contractors to try to get them tooled up so that they have the capabilities of doing those different types of foundation installations, so that if you do have a site that's small and you really can't justify doing geotech ahead of time, you can have this contractor come to site, and he's not going to basically back you into a corner where you need to make one type of foundation works. I want to go back to what Vishal said earlier. We aren't foundation agnostic. We don't think that one foundation can resolve all of your subsurface challenges. You need a multitude of foundations to combat different subsurface conditions. So obviously, having a contractor that is going to work with you and be flexible to do those different types of installations is going to help. And JP, if you like, I could actually connect you with one of the contractors we're working with here in Ontario on that topic. Okay, so the next question is coming from Natalie Melanson, who asks, how do you overcome high slope conditions? 40-degree hills, for example. It's a very good question. So actually, now, maybe I can ask a follow-up question, Melanie. Is that slope a constant slope? And what I mean by that is it uniform 40 degrees from top to bottom, or is there any undulations? I'm going to assume, for the purpose of this question right now, that it's a uniform slope, basically uniform. Okay, amazing. So, I mean, everybody knows what happens when you take a 40-degree slope and you rotate it 40 degrees. It becomes flat. One of your larger challenges isn't the racking system, isn't the foundation system. It's actually the installation. So you need to be able to select an installation method that would be able to work on that 40-degree slope. Now, that may require, depending on exactly how steep that slope is, exactly what your foundation design is, exactly what your pile orientation is, maybe doing some grading, which I know is kind of like one of the words a lot of solar developers do not like to hear. It may involve doing some grading, or it may involve obviously shopping around and looking for a contractor that could install on that slope. I can tell you that we've done projects up to, I want to say 35 degrees, maybe even I want to say 38 degrees. So, we're not far off of 40. We're not far off 40, but it's definitely doable. And as my colleague Keith just mentioned in the chat, this is where the preliminary site visit really comes into play, because if we come and do that preliminary site visit, that is one of the things that we are checking is your ground conditions, and specifically the slope and topography. So if we know ahead of time that we're going to be dealing with a 40-degree slope, we will be keeping that in the back of our head, and we will be talking with the contractor on that project to make sure that the design we are proposing to install is feasible. And remember, as part of the process, I recommended to do that pre-production testing program, and we're doing a construction feasibility. So we are going to be able to get real life information, real life data on how suitable is this foundation for that topography. Now the one thing I want to so let's assume, Natalie, that your site wasn't uniform, and so you've got undulating slopes. That one's a little bit tougher to combat, but one thing that we've recommended in the past, I mean, obviously you can grade, but like I said, grading is very expensive, and it creates a lot of other challenges with the project. There's a lot of soil erosion control measures that need to go into place if you're doing a major earthworks program. So if you can avoid that, that's great. One thing we've done in the past is, instead of grading, we've upsized the size of your post to accommodate a higher moment resistance. So if you picture it, if your rack was 1 meter off the ground, but then, in order to accommodate the grade, maybe it needs to be 2 meters off the ground. So all of a sudden, you're increasing the moment acting on that pile by 2. So in order to obviously increase your resistance, you're going to have to play with the dimensions of that pipe, or maybe increase the strength. There's a lot of different things that could be done, but we could let the steel do the work for us instead of having to do a grading program. Okay, so our next question comes from Dave Nepali, which asks, how do you ensure that the bearing capacity of the soil disturbed by pit excavation? So, sorry, Dave, if I'm just understanding that correctly, what you're asking is this specific to doing a geotechnical investigation during using a test pit method? And how are we ensuring that we're getting in situ undisturbed values? Okay, perfect. So I don't know if you're familiar with a dynamic probe test. It's very, very similar to an SPT, and so we would actually do that test in undisturbed soils, maybe just to the side of the test pit. We may do it a lot of times we'll do it at surface before we start the excavation. We'd excavate to a depth where it's safe for the technician to enter, which is universally about 4 feet. In some cases, it may not be safe to enter a 4-foot excavation, and obviously our staff are trained to assess excavations before entering them. But we'd also do an in situ test at about 4 feet. So that'll give us, about a 10-foot profile of in situ shear strength at the site. And the key is we're doing that in undisturbed soils so that it is an in situ representative test. So I hope that answers your question. So that concludes the current questions. If there's anything else, we do have 4 more minutes. So by all means, if anybody else has any more questions, please go ahead. Okay. Well, thank you very much, everybody, for joining us. I don't know, Vishal, if you've got any closing notes or remarks you'd like to add.
No, just thank you very much for joining us. It was a great turnout today, and hopefully you all got some good value. And we have, I think PRI is having another one of these on October 8th. So please join us there as well, and Polar will be having a few more webinars coming up as well. So yeah, thank you very much, and thanks for the questions, and thanks Rash for the great presentation.
Okay, perfect. So we will have a recording of this sent out to all the attendees. If there's any questions, please don't hesitate to contact myself. You can just use the generic email on the screen right now, and it will be directed to myself, and I'd be happy to answer any questions you may have about this presentation, or if you've got a specific project you want to discuss, I'd be happy to look at that for you as well. Okay, thank you very much.